In this video, we'll do the integral of ln of x squared plus 1 a different way. So the integral of 1 over x squared plus 1 will be the integral of 1 over, we're going to factor this as x minus I times x plus I. So this will be partial fractions, so something over x minus I plus something over x plus I. So when we plug in x equals I, we're going to cover that up, that term up, x minus I equals 0. We'll plug that in, so that would be 1 over I plus I, which is 1 over 2I. You can do the same thing here, and you get negative 1 over 2I. So this will be 1 over 2I integral of 1 over x minus I minus 1 over x plus I. So this will be 1 over 2I. You integrate each one, you get ln's of something minus ln of something. So ln, the top will be x minus I, the bottom will be x plus I, absolute value still, plus c. And you know integral of 1 over x squared plus 1 is inverse tangent x. So let's plug in x equals 0. So we get a nice identity. So we get 1 over 2I ln x minus I over x plus I. And this will be equal to, when we plug in 0, so 0 minus I is negative I over I. That would be negative I over I, which is negative 1. Absolute value of negative 1 is plus 1, but without the absolute value. Ln of 1 is 0. Plus c equals inverse tangent of x being 0 is 0. So we get that c is 0. So we get that the inverse tangent of x will be, so 1 over 2I can be written as times I on the bottom and the top. So this would be I times I is negative 1. So this would be negative I over 2. So we get negative 1/2 times I times ln of x minus I over x plus I. Then we're going to multiply by 2, and you'll see why later. So this would be the 1/2 and 2 will cancel out, so you just get negative I times ln absolute value of x minus I over x plus I, and it doesn't have to be absolute value. So the integral of ln of x squared plus 1, you can write it as same way, basically x minus I, x plus I, but we're dealing with natural logs, so we can split those up. So plus ln of x plus I. And we also know that the integral of ln of u is u ln u minus u. So this will be plugging in x minus I for u, you get x minus I ln of x minus I. And then we have minus x minus I plus x plus I ln x plus I minus x plus I. And then we can take the real part of this, because the integral of ln of x squared plus 1 is in the real numbers by definition. So this will be the real part of, so we have x ln of x minus I. Actually, let's factor out the x first. So we get x times the quantity ln of x minus I, and then we have another x here, so x times ln of x plus 1, so that'd be, we can add ln of x plus 1, I, not 1. You can combine those back together to be x minus I times x plus I, which is, like in the beginning, x squared plus 1. So we're going to write this as x times ln of x squared plus 1. So that will simplify. What else? So we have plus, we're going to factor in a minus I, so we're going to have ln of x minus I in parentheses, and then we have another minus here because this is plus I, ln of x plus I. Like again, we can combine those two by doing division, so this would be x minus I over x plus I. And then finally, minus I and plus I will cancel because they're opposite sign, you're adding them. Minus x is minus 2x. So this will be, the real part of x times ln of x squared plus 1 is itself, because they're already real numbers. X times ln of x squared plus 1. The real part of this value here, we got, excuse me, that was a mistake. So that would be from above, we have 2 inverse tangent x. So the minus I ln of x minus I, x plus I, is 2 inverse tangent x. So we're going to write plus 2 inverse tangent x. And inverse tangent x is a real number, so this is okay. So minus 2x. And we have plus c, and that is the end of the video.